Hi, this is Dr. Derek Brown, and here's your introduction and syllabus review for ATOC Environmental Science and Geography 3600, Principles of Climate. Here's my email, derek.brown@colorado.edu. Please feel free to contact me whenever you need for questions about the course. Even though I've listed my office and campus phone and campus box here, please email me during this course because I won't generally be on campus during its run. We do have a required text, and that's Climatology by Hador et al., the third edition, by Prentice Hall in 2010. Now I'll just show you a short video about my teaching philosophy and we'll move forward with the syllabus review. Here I am in early May, right before finals, getting done with this course, the development of this course, which I'm pretty happy with how it went. It's obviously going to be invaluable for me to get your feedback at the end of this course, since this is the very first time I've designed an online class and implemented it as well. In general, my teaching philosophy is to construct a scientific framework for you as students so you can move forward and apply that scientific framework to different challenges and ideas. And you'll really be able to piece together arguments for or against certain ideas that are floating around. I also promote critical thinking skills and encourage discovery using them in the future as students. Lastly, I understand that students learn in different ways. There's a spectrum of students here. All are very interested and curious. They just learn in very different ways. So I try to give students different options for learning that make sense for them. So my general philosophy there for online course here is just to give you a variety of tools, whether it's video recordings, or it's book chapters, or it's numerous worksheets that you can use to understand the material, whatever it takes for you to really gain the understanding to make you successful in the quizzes and the exams and also active discussion posts. Even though I've laid out a variety of tools for you for this course, I still would like, if you need further clarification in anything, or if you want to explore a topic further, reach out to us. Reach out to the TA, Anando, or myself, and we really can help you. Just because we're not meeting live in this course doesn't mean we should treat it like a bubble. Just a quick bio about me. I started getting interested in weather and climate by working at the Mount Washington Observatory, which is located on a 6,300-foot summit in New Hampshire. There was a number of research projects going on here when I worked there as well, and that really piqued my interest as far as getting into research and going to pursue my graduate career. During that time, I was studying water vapor, and more specifically what are called isotopes in water vapor. We could look at the distribution of heavy and light water in the atmosphere and get a more refined idea of what the water budget's doing. This brought me on some field campaigns to the Mauna Loa Observatory, which is well known for measuring atmospheric CO2 in the long term as well. So our instrument was measuring water vapor from a satellite that NASA had built. As the satellite came over at 2 p.m. and 2 a.m., we took additional measurements at the surface of the Mauna Loa Observatory, therefore learning how to calibrate that satellite instrument. And here's just an example of the satellite data itself, showing a profile of this isotopic composition, which gives us again some information about water vapor in the atmosphere. And it's showing definitely a distinct signature over the Amazon, this convectively active region. Now I'm still a bit active in research, however most of the time you'll find me teaching these days, and I really do enjoy teaching. So I've been an instructor for ATOC for the last 4 years, teaching a variety of courses. So I see a variety of students and a variety of disciplines by teaching all those different courses. When I have free time in the winter or otherwise, you can sometimes find me skiing. I enjoy backcountry skiing with a lot of friends, and more I ski with my 2 children quite a bit, the mountains as well. These 2 guys keep me pretty happy and pretty busy as well. Other activities I like in the mountains: camping, hiking, mountain biking, any kind of photography. Here are my drones flying over the Rio Grande. I'm trying to learn how to get better at using this to my advantage as far as filmmaking and looking at documenting weather events, etc. I'm extremely happy to have our teaching assistant, Anando, on board with me. He has worked with me before in an introductory climate class many years ago. He got his Bachelor's of Science from Cornell, and now he's in his 4th year as a PhD student with us at ATOC. He has experience teaching weather and climate both at CU in a TA form, but also as the main instructor at Metro State. So he has some good teaching experience. His research, now in his PhD, involves particulate chemical composition effects on air quality and visibility degradation. And this has taken him for a couple field campaigns in Asia to explore this. Personally, he enjoys hiking, reading, painting, and yoga. For this course, Anando will really help facilitate discussions, and he was very involved in actually creating the discussion topics and questions in general as well. He'll also help to evaluate homeworks and discussion posts. Just like I am, Anando is more than willing to answer questions about course content and concept. If you need further explanation, contact me or Anando. So more pointed objectives. By the end of this course, you should be able to do the following things. Recognize and classify the roles and couplings of geological, chemical, physical, and biological processes in the complex Earth system. We'll identify and explain the dynamics that drive atmospheric winds and ocean currents across all temporal and spatial scales. So we'll look at different scales of motion, what's important at which levels, etc. We'll relate the global distribution of energy to regional temperatures and heat transport processes in the atmosphere and oceans. We'll employ surface energy budgets to diagram differences in regional climates. So beyond global climate dynamics in this course, we are definitely going to have a look at regional climates, what separates climate regimes around the world as well. We'll also examine and describe the numerous roles of gas, liquid, and solid phase water within the climate system. Water is extremely important for energy budgets and a variety of things. Anytime water changes phase, for instance, there's a transfer of heat, latent heat. It's extremely important that we understand water vapor and clouds as well. You'll objectively interpret and synthesize direct observations, remote measurements, such as from a satellite, and model results to solve challenging climate problems. We'll discriminate between anthropogenic, human-caused, and natural signals in the modern climate system. And finally, evaluate future climate change scenarios using logic, critical thinking skills, and examples from the past. Your responsibilities are as such. Please reserve about 75 minutes a day to go through the online material, which would be the video lectures and the exercises. 2 hours per week to grasp the reading and online material and participate in the discussions. Roughly 2 hours per week to go through the homework assignments, where there is one weekly. About 75 minutes for each exam, 2 exams total for the whole semester. And then about 10 minutes for each quiz, which happen twice a week. So in total, you need to reserve about 2 hours a day to go through material. These summer courses really move quickly. It is very important that you do not fall behind. I can't emphasize that enough. They do move quick. You're cramming a whole semester into 5 weeks. We're doing it online. I know there's a lot of material here. There's a lot of videos. There's a lot of exercises. You got to do your best to try to keep up with the material. If you can do that, I bet you'll do just fine in this class. I really do. If this is your first time taking an atmospheric science course in general, reserve some additional time to review basic concepts as well. And I've tried to add a bunch of remedial worksheets at the beginning of the course for those people who have no experience in atmospheric science whatsoever. Our formal communication policies. I'm available Monday through Friday by email. Emails will be answered the same day they're sent, except emails after 8 p.m. Mountain Daylight Time will likely be answered the next day. In general, I'm pretty quick at getting back with my students. I will read email over the weekend, and I will try to reply to emails within 24 hours. There's also Anando. Anando is also around as well, so for more urgent questions, please copy the teaching assistant, so that way you have a better chance that one of us will be able to reply very quickly. So this is the schedule of our course here and seeing what's happening. The most important parts here are that we have a homework every week that happens on Thursday. So 5 homeworks over the semester, 2 quizzes on Wednesday and Friday most weeks, so about 9 quizzes for the total. And then we just step through the chapters of the book in general. And definitely watch the video recordings because I add a bunch of information that the book doesn't cover appropriately. So we'll start out looking at general energy in the climate system, how it feeds into atmospheric temperatures, how atmospheric humidity plays into that, looking at the wind belts and circulations, looking at circulations in the oceans, looking at interactions between the atmosphere and the ocean, things such as El Nino, and then actually something you probably didn't expect in a climate course, looking at synoptic climatology and climatology of atmospheric storms. So looking at the distribution of extratropical cyclones, hurricanes, other types of storms, you can look at that in a climatological sense. For instance, see if they're increasing over time. Then we get into a little bit of paleoclimate, climate in the past, looking at natural causes of climate change, both present day and in the past, looking at how we reconstruct our ideas of past climates through ice cores, pollens, etc., looking at the global carbon cycle, Earth's greenhouse effect, physical changes to the global environment. This would be things like ice melt or sea level rise, looking at how the living world is responding to climate change, looking at ecosystems, things like that. Finally, looking at ozone depletion, and then going back a little bit into regional budgets, really understanding, now that we have a really background, a foundation behind us, understand what makes the difference between tropical, mid-latitude, polar, and highland climates. And then finally, we'll wrap up with a discussion the last day on what you think about global climate change. What do you think are the best solutions, etc. So we'll basically brainstorm together to see what we all think about the best ways to move forward, both as a country and also as a civilization. More specifics, homework. 1 homework assignment per week. All assignments are posted at the beginning of the course, so they're out there as soon as you can get access to this course. The weekly deadline for the assignment is Thursday, 11 p.m. Mountain Daylight Time. Homework submissions open 7 days, starting the Thursday of the previous week at 11 p.m. Mountain Daylight Time. No late homework assignments accepted. So therefore, the submission button in the D2L Dropbox has to be pressed before the deadline of 11 p.m. Mountain Daylight Time. If there's some reason why you cannot hand in work on time, you have to contact me or Anando well before the day it is due. The lowest homework of the 5 total is dropped. So in case you have some kind of extenuating circumstances, that's why that policy is in place, that you get to drop one automatically. So for the homeworks, you're going to have a PDF that you're going to have to download, fill it out by hand, maybe draw in some graphs, write in answers, and then you're going to have to scan it and upload it as also a PDF to the Dropbox. Now there's information on our website on the best way to do this, and DocScan is one of the best apps available for doing this, and it's not very hard, and it's certainly worth your effort to finding out how to do it for this class and in general. Quizzes. There'll be 2 D2L type quizzes per week. They're very short. Each quiz has just 6 questions and a 9-minute time limit with only 1 temp allowed. This is basically motivation to keep you guys reading, keep you guys engaged, keep you guys up with the course, because you really do not want to fall behind in one of these accelerated 5-week courses. The quizzes can be submitted between 8 a.m. on Tuesdays till 11 p.m. on Wednesdays for quizzes 1, 3, 5, 7, and 9, and 8 a.m. to Thursday till 11 p.m. Fridays for quizzes 2, 4, 6, and 8. Your lowest quiz grade is dropped automatically. Discussions. There's roughly 1 discussion question per week based on the reading or online video presentations. Your grade will be based on accuracy, participation, and relevance. The discussion questions should be addressed by Mondays at 11 p.m. Mountain Daylight Time. I will say the 5th discussion happens on the last day of class, Friday, July 7th, and so you must answer by 11 p.m. on that day. Submission is open from 11 p.m. the previous week until the due date. Again, discussions 1 through 4 are due on Mondays, 11 p.m. Discussion 5 is due July 7th, the last day of class, Friday at 11 p.m. All discussion questions are posted and are visible right now at the beginning of the course. Like everything else, you need to submit your discussion post before the deadline. Exams. Both exams are in D2L quiz format and will be posted the Friday before the due dates. The due dates are for Exam 1, June 23rd, 11:30 p.m. Mountain Daylight Time, and for the final, July 6th, the second to last day of class, Thursday, July 6th. That's the deadline for that, 11:30 p.m. Mountain Daylight Time. Both exams will test on the material covered before the respective dates. 1 attempt's allowed per exam of 75 minutes in length. So the general grading criteria for this class, quizzes, top 8 of 9 will count. In total, that category counts for 20% of your grade. Homeworks, top 4 of 5. Homeworks are worth 30% of your grade. Discussion post, there'll be 5 total. Your average grade there will be 20% of your final grade. Exam 1, the midterms worth just 12%. Exam 2, the final worth 18%. So the homeworks are worth as much as both exams, which is kind of unusual, but the homeworks are one place where you can actually write out answers. We're going to spend our time evaluating what you're saying. You get plenty of feedback there, so that's why we did that. Final letter grades are pretty standard, and you can look in the syllabus for specifics here. If grades are anomalously low for some reason, I will introduce a scale at the end of the course and keep you updated about that. Other information is available in the written syllabus or a web page of the syllabus online, looking at submission policies, techniques, again, how to upload things, technological requirements, online classroom behavior policies, discrimination and harassment policies at CU, honor code violations, disability accommodations, religious observance policies. Again, all this is found in the syllabus in the Getting Started folder. Be sure you look at the syllabus and read through it yourself and get started with this course. It should be fun.